All right, everybody. So, working on some integration here. Got a little bit of a nasty looking integral someone asked about. Um, the integral of e to the negative x sine of 3x dx. And so, when I look at this problem, I know u substitution won't work because neither function's derivative shows up in the other function. And so I think integration by parts. The tricky thing about integration by parts is neither piece really gets better. They stay both exponential, they stay trig. So there's no, like how a polynomial gets easier as you take its derivatives. So I'm just going to go set u equal e to the 3x, dv equal sine of 3x dx. No particular reason. I just have to choose one of them and go from there. So I take the derivative of e to the negative x. I take the antiderivative here. So the antiderivative of sine is cosine. Because there's a 3x, I divide by 3 to do the antiderivative. It's the reverse of the chain rule right there. So my original integral is equal to, according to integration by parts, uv. So I'm just putting that negative in front, minus the integral of v du. Okay, so there's a lot of negatives going on there. These two negatives can become positives. This is multiplied. It's not added. It's just a positive term there. Okay, things did not get much better. I still have a trig and an exponential. So when you're doing integration by parts more than once, try to choose the same type of thing for your u and dv on each step. So I'm not going to switch making u my cosine. I'm going to keep u as my exponential part. So u equals e to the negative x, dv equals cosine of 3x over 3 dx, du equals negative e to the negative, there's the negative e to the negative x dx. Antiderivative of cosine is sine. I divide by another 3, so I get to a 9. So I'm still going to copy this chunk down. Minus, and then I'm going to do minus a whole uv minus v du. So minus u v minus the integral of v du. So now what I recognize is that the original integrand is showing up again. This original integrand here is almost replicated here. So I'm going to call the original integrand I for integral. So I is equal to all of this. Let's distribute it out and see what we can say. I is equal to this part minus this part and then here I had a minus and another minus, so when I distribute my negative I'll have a minus, and the 9 can be brought out in front. 1/9 times the original integral. So now it's just solving for I. I'm going to add 1/9 I to both sides. So 1I plus 1/9 I makes 10/9 I. So 10/9 I equals all of this stuff. And so then I'm going to and I don't have much space, so I'm just going to multiply by 9/10. So just pretend I wrote that step there. So then I is equal to 9/10 times the stuff I just underlined. Negative e to the negative x cosine of 3x over 3 minus e to the negative x sine of 3x over 9. Now, a nice exercise for you to do is to, if you have time, is to go back and actually take the derivative of this expression at the end and make sure that its derivative comes back to the original integral. And you can see why this is possible if you realize that you're going to be doing some product rule here. And so you'll be doing a lot of like f prime g and then f g prime, f prime g, and f g prime. And so you're going to get some things that cancel each other out. And you'll be left over with the original integral. There's one last thing. Make sure you get a plus c on it. You don't want to lose that 1 point just because you forgot the plus c on your indefinite integral. So there you go. Thanks for watching. Please comment, ask questions if there's anything I can do to help.